So if I ask you to simplify something like this, the directions tell me assume all variables represent positive numbers. I told you yesterday you don't really need to worry about that. It doesn't change how we solve it. It's just a common phrase that you're going to see when you're working with these. So where would I begin on the first one? We need to take our exponent through, so we will start there. So my first parenthesis will just stay the same. Okay, this is like a y to the first. When you bring that 1/2 through, what are you doing with your exponent? Well, you could, but first let's simplify just with the multiplication. Power to a power with multiply. So -2 times 1/2 is -1. Y is 1 times 1/2 is 1/2. Now what do we do? Okay. So you have different options. One option is if you don't like the negatives, rewrite the problem so it doesn't have them. And if we do that, it moves that x to the -1 down. Everything else stays on the top. If you are multiplying the y and the y to the 1/2, what do you do with their exponents? Add them. So 1 plus 1/2 is 3/2. What would I do with my x's? The x's are divided, so we subtract their exponents. Will it end on the top or the bottom? What's bigger, 2/3 or 1? 1, so it'll end on the bottom. If you brought it up to the top instead, you'd have 2/3 minus 1, which is -1/3, and a negative tells you move it to the bottom. So you'll get it either way. Or you could realize the 1's bigger. So if I subtract down here, 1 minus 2/3 is 1/3. All right, now we can certainly do more with this if we wanted to change it all to radicals and work with those, but our directions were just to simplify this. Okay, it never said that my final answer had to be written in radical form. So this is okay. We can leave our answer like that. Let's try another one. Two x to the 1/3 over y to the 2/3. And that whole thing is to a -3rd power. If the whole thing is to a negative, what will happen to my fraction? It flips. So we have two options. We can either start distributing the -3 through, or we could realize if I don't want everything to have a negative exponent, I can just flip my entire fraction. And once I do this, it's now a +3 out here. So that just saves us some work later on. So now if I take everything to the 3rd power, you will multiply your exponent. So 2/3 times 3 is 2. On the bottom, this is 2 to the 3rd. X 1/3 times 3 is just 1. What is 2 to the 3rd?
8.
Y squared over 8x. I want you guys to try a couple. don't you do C? I'll do D with you, and then I'm going to give you guys a different one. There's really two options for where to begin. How many of you took the 1/2 to everything first? Did anyone simplify inside the parentheses first? All right, both options work. Okay, you should get the same answer either way. Look like the majority of you took the 1/2 through. So if I did that, it becomes 9 to the 1/2, x to the first, y to the 1/6. X 1/3 times 1/2 is 1/6, and y the 1/2. All right, 9 to the 1/2. A 1/2 is the same thing as saying a square root. What's the square root of 9? Then my x's. So this is a 1. So if you subtract 1 minus 1/6 is 5/6. With our y's. What's bigger, 1/2 or 1/6? 1/2 minus 1/6. I think you multiplied. Does anybody need help with fractions on their calculator? How to use it? Let's look at D together. This one has a lot. Where would we have to begin? The exponents. So I have to take this 1/3 through. So we would get x to the 2/3, y to the 1/3. This one, if I take my 2/3 through, x to the 2/3, y to the 4/3, and I still have the denominator. All right, what now? Combine our like terms by adding our exponents. So on top, we can combine our x's. 2/3 plus 2/3 is 4/3. Combine our y's. 1/3 plus 4/3 is 5/3. So I'm just adding those exponents. Remember, it's all one term, all one multiplication problem, so you can do it in any order. And now, if we're dividing, we subtract our exponent. So 4/3 minus 2/3, 2/3. 5/3 minus 2/3 is 1. So x to the 2/3 and just y to the first. Any questions there? You guys simplified this problem. A power to a power, the m is written each time, so you add your exponents. 2/3 plus 7/3 is 9/3, which is just 3. Okay? 1/3 plus 2/3 is 3/3, or just 1. So you get m to the 3rd plus 2m. Those are added, not multiplied, so I can't do anything else, not like terms. Alright, any questions on dealing with these fraction exponents? Same thing as regular exponents, same rules, just looks a little bit different. I want to practice evaluating some numbers, maybe without a calculator, to make sure we actually know what these things mean. So if I say 36 to the 1/2, and I told you don't just plug it in the calculator, let's think about it. What does a 1/2 power mean? Which is negative 1,296 to the 1/4 power. What happens if there's a negative on the outside?
You put a negative on the outside of the radical, and so it'd be times the negative.
Very good. So since it's not in parentheses, negative is outside, a 1/4 is a 4th root. Alright, if you need to, you can use your calculator. What is the 4th root of 1,296? The 4th root?
Probably 12.
It's 6. Anybody need help putting a 4th root in here? You can either type it in as a 1/4 power, or you can type in the 4 for the 4th root, go into map. And I think it's like number 5, it has a star and then a radical. And that will do your 4th root for you. Everybody get that? Okay. Let's go down to, skip that one. Go to D here. Negative 27 to the 2/3. How is this one different? In parentheses. So, a 2/3 means we have a cube root of something squared. The negative 27 is under here. Now the square can either go on the 27 or after the radical, it doesn't matter. Cube root of negative 27. What to the 3rd power equals negative 27? And it would be a negative 3, right? Negative 3 times negative 3 is positive 9 times negative 3 is negative 27. And negative 3 squared. Negative 3 times negative 3 is 9. Last one of these. If I say 16 to the negative 3/4, does the negative just go in front? That's it. It's on my exponent. What does a negative exponent mean?
It goes over one.
It's 1 over. It moves it to the bottom. So you have to watch. Is my negative out in front of the number? Or is it in the exponent? If it's in the exponent, that just moves it to the bottom. Okay, a 3/4 power means we have the 4th root of 16 cubed. What is the 4th root of 16? And 2 to the 3rd is 8, so we get 1/8. Now I am fully aware you could all just plug every one of these into your calculator and get the answer immediately. I know that. But we are going to continue working with radicals the first few days of next week, and we'll have variables, so we need to have an understanding of what these things mean. Okay, so I'm showing you with numbers to try to get that understanding before we move on next week. Any questions there? Then one final piece that we need to look at today is factoring. Okay, we have done a lot of factoring so far. But our factoring, all of our exponents have always been whole numbers. Okay, we've never had fractions, we haven't had negatives. So we need to kind of look at a few where the numbers aren't as nice and make sure we know how we would factor it. Our rules don't change. So in factoring, what do you always look for first? Greatest common factor, and that is the case no matter what kind of problem I give you. So if I'm looking at this one, how many terms does it have? 2 terms. So looking at each term, the coefficients, 28 and 21, I could take out. Okay.
7y.
And then we look, they both have y's. Now, if I said 28 y to the 5th plus 21 y squared, if those exponents were positive, how many y's would you take out?
2.
2. Why?
Because that's the most you can't take out.
Right, 2 is smaller than 5. If my exponents are negative 5 and negative 2, which one is smaller? Negative 5. So I'm going to take out 7y to the negative 5th. Okay, I'll show you why right here. So 28 divided by 7 is 4. I had y as a -5 and I took it out, so that's 21 divided by 7 is 3. When you take it out, you're dividing it, right? So it's really subtracting that exponent. -2 minus -5 becomes y to the third. So you'll know you've done it correctly if what's left in the parentheses has positive exponents. If we had taken out a -2, then we would have had a y to the -3rd left on that first term. And we want positive exponents in our parentheses.
So then would you put the whole thing over y to the -5?
You can, it's equivalent. My directions were just a factor, so this is an acceptable answer. But if you didn't want to, if I said in my directions, write it without any negative exponents, then you would have to drop that y down. All right. Try a similar one. This one has fractions, but same idea, 2 terms. What number can I take out of both terms? 6. Then with my ends, you look at your exponents, you take out the smallest. What's smaller, 4/3 or 1/3? 18 divided by 6 is 3. When I factor it out, it's like subtracting my exponent. 4/3 minus 1/3, 3/3, which is 1. 12 divided by 6 is 2. Into the 1/3, I took all of that out. So that's my final answer. So if I am looking at this one, how many terms are there? 2. This is a term, that whole parenthesis, there's a minus, so this is the second term. In these terms, they both have x plus 3. So I am going to take out x plus 3. If I take that out, I'm going to put a bracket here just because I already have parentheses. I don't want that to be confusing. We have to take out the smaller power. What's smaller, -2/5 or +3/5? So that's x plus 3, the -2/5 we're taking out. If I took out the whole thing here, what am I left with? 1, right? It's like dividing it by itself. 2 divided by 2 is 1. Minus, over here, I still have my x plus 3. If I subtract -2/5, it's 1, so it's an x plus 3 the first. Alright, can I clean that up at all? Say inside we probably can. We have x plus 3 and -2/5. We distribute. So we have 1 minus x minus 3, so 1 minus 3 is -2 minus x. So we kind of combine some like terms to clean that up.
Is 1 negative?
The 1 was not. So this one right here came from when I factored that whole thing out and I divided, so it became a +1. But if I asked, we could actually do one more thing. What could you take out of that parenthesis? A negative. If you do, you just bring it all the way out to the front. And that would give me a 2 plus x. So we could certainly do that if we wanted. was a little bit uglier. I really just wanted to show it to you so you realize when you are factoring, it doesn't have to be just a single variable. You can be pulling out an entire parenthesis. Okay, and we'll see more of that later on. I just wanted to start including it here and there. Any questions for me over what we have done today? Then I want to put up a couple review problems that I would like for you to look at. All right. First problem. Z minus 4 over Z plus 6 plus Z plus 5 over Z minus 7. I'm going to put 2 up here. I want you guys to go ahead and try. So for the first one, if you have to add or subtract, what do you need to get? Common denominator. Every single addition and subtraction problem. You want to check if your denominators can be factored. If they can, it will give you you want to factor before you do anything else so that you have the easiest possible problem to work with. But when I look Z plus 6 and Z minus 7, nothing factors. So what would I have to take the first fraction times? You do it on numerator and denominator. Second one, Z plus 6. Okay, so then we FOIL on top, so Z times Z is Z squared minus 7Z minus 4Z plus 28. Denominator, you certainly can multiply it out, but it's probably easiest not to. Second one, if we FOIL, we get Z squared plus 6Z plus 5Z plus 30 over to Z plus 6Z minus 7. The denominators are the same, so I can put my fractions together. We're adding like terms. So Z squared plus Z squared to Z squared. Negative 7Z, negative 4Z, 6Z, and 5Z. Nothing. It's negative 11Z and positive 11Z, so that cancels. 28 plus 30. At this point, you could, if you wanted to factor a 2 out of the top, you can, but does it help me reduce anything? No. So either of those is okay for our final answer. Alright, so if you're adding and subtracting, you need a common denominator. If we are multiplying or dividing, what do we do?
If you were dividing, you do the reciprocal.
Mm-hmm.
First you would factor.
Yes. So x plus 6, x minus 3 over x plus 7, x minus 3. This one, x minus 7, x plus 2 over x plus 6, x plus 2. So the only difference, if you're dividing, you have to flip the second one. So now we are looking for anything that's the same on top and bottom. So I can cancel +6, the -3s, the x plus 2s, and all I'm left with is x minus 7 over x plus 7. You can't reduce anymore because those are both 2 terms, so we are done. Okay. So you have that math Excel assignment we started yesterday. That one is due Monday, and we'll start the next section Monday. So get the rest of the hour to work on that and ask questions